This meeting is now being recorded.
Good afternoon, everybody. This is Tammy Katz, chair of the Requirement Working Group within INCOSE. I'm very happy to have you all join us today. We've tried to have monthly web meetings throughout since IW for sure. Today, we have a couple of guest speakers representing the Reuse Company. They're going to present a comprehensive guide on tailoring our own guide for writing requirements. And so it's a great pleasure to see this particular document brought up today and see their particular spin on providing guidance to it. So I'm going to go ahead and ask anybody calling in to mute their phones, please, and I'll be trying to monitor that throughout. This is recorded, and so the recording will be available on our Requirement Working Group SharePoint or Connect site once the meeting is over, likely within a day or so. And the slides will also be available, and we'll go ahead and have the slides sent to me, and I'll be able to upload those pretty quickly today. So without further ado, I'm going to go ahead and turn it over to Jose and Elias. And hopefully you guys can enjoy today's talk. Go ahead, gentlemen.
Thank you, Tammy, and thank you everyone for joining us. I hope you enjoy this session where we will be showing you a tailoring guide of the INCOSE guide for writing requirements. That I'm proud of sharing all this content with you. The content of this webinar starts with a very brief introduction to the Reuse Company and also to the speakers. I have just one slide introducing the INCOSE guide for writing requirements, because I do think that probably you all know what is this guide and what is the content of this guide. So we will be focusing on the challenges of this guide, what are the trade-offs that we have found with this guide, and we propose a solution. The final block would be a quick quiz. We would like to receive your feedback and to learn from you what is the current situation in your organizations with regards to the implementation of the INCOSE guide for writing requirements or other guides. And the last block is we are proud to announce here that today we have just released a version of this tailoring guide as a book. So this book is available in our website, and I will be proud to show you this book and to show you how to request for a copy of this book. So without any further ado, let me just have this quick introduction to the Reuse Company. For those of you who still don't know us, our company provides a knowledge-centric approach to leverage systems engineering activities. The company was created now over 20 years now, in 1999, as a spin-off of a university in Madrid, Spain. And now the staff is a nice combination of software engineers, systems engineers, artificial intelligence people, natural language processing. So I do think that this is the best combination possible to achieve the goal of having an approach on how to analyze textual requirements. The headquarters is still in Madrid. We have a small office in Stockholm and a delegation of our company in Tokyo, in Japan. Our plan for this 2020 was to open a new office in the US. However, due to this COVID-related situation, we have postponed this until next year. And our vision and mission is to promote reusable and scalable global solutions to a smart, interoperable systems engineering environment by offering, as I mentioned before, a semantic knowledge-centric approach, like the one I will be sharing you today. So final slide for the Reuse Company, just to make it simple, especially here in Spain, we like to use the acronym TRC. Not only because TRC is the acronym of the company, of course, but also because TRC is also the acronym of the three main disciplines that or pillars that we cover in our tools. If you allow me a little trick here, and replacing the C by a Q, because quality in Spanish is spelled with a C, while probably in the rest of the languages in the world is spelled with a Q. So after this quick change, then we can say that we cover T for traceability, R for reuse and reusability, and Q for quality. Of course, the topic of today's webinar is quality, so we'll focus on this Q, and I will keep traceability and reuse for other moments in time. Quickly, because you will have a copy of all the slides and a copy of this video presentation, but quickly speaking, I'm Jose Fuentes. I'm the Chief Operating Officer of the Reuse Company, and one of the teammates that was founding the company, creating the company from the very first moment. And together with me, the second part of the presentation will be taken by my colleague, Ilias Jusli. He's a sales and consulting engineer at the Reuse Company as well. So let's go right to the point with a brief introduction to the INCOSE guide for writing requirements. For those of you who still don't know this guide, I do think that this is a worldwide reference on the topic of writing high quality requirements. Most of the people probably know this guide because of the classical 41 rules in this current version, rules to be followed when writing requirements. However, the guide is much more than this. The guide starts with high-level quality characteristics, both for individual requirements and also for the quality of sets of requirements, let's say a requirements document, requirements specification, or even a folder containing different requirements and documents. So together with the characteristics at the high level, now in this version, 9 characteristics for the quality of individual requirements and 5 characteristics for the quality of a set of requirements. Then mapping these high-level characteristics, we have kind of 41 quality rules for the quality of mainly individual requirements. This is one of the topics that I would like to mention today. But these quality rules are mainly addressing the quality of individual requirements and not the set of requirements. At least this is the way we see this guide. And then the final block is related to a number of different attributes, 46 possible attributes for the quality of your requirements, right? So having said that, it's a very brief introduction. Let me now highlight some of the challenges that we have found in this version of the INCOSE guide. And after that, my colleague Ilias will take over with some possible solutions and the tailoring guide itself. So first of all, some pros and cons of this INCOSE guide. As I mentioned before, I do think that this INCOSE guide for writing requirements, is representing the state of the art with regards to tricks and tips on how to write high quality requirements. Of course, there are plenty of other guides or guidelines, or let's say the NASA System Engineering Handbook itself is including as well an appendix on how to write high quality requirements. Similarly, here in Europe, we have the standards from the European Space Agency also describing tips and hints on how to write high quality requirements. But regardless, if you are an American company, European company, an Asian company, I do think that most of the companies are I don't know if following, but at least knowing this INCOSE guide for writing requirements. So having said that, I do think that this is the best starting point when you start the journey of improving the quality of your requirements. So I'm very proud of being considered as one of the major contributors to this guide as well. However, now if I move a little bit forward and I start speaking about the cons, this is my own experience and my humble opinion after studying with a lot of different companies all over the world on the topic of high quality requirements. I do think that one of the main challenges is that this guide is most of the times considered like a guide written in stone, if I can say that. So something like a fixed number of quality rules that you cannot or you should not tailor or modify in any possible way, while this is very far from reality. But this is my own experience. And together with this, the consideration of these 41 rules in the INCOSE guide, like like a single set of quality rules to be applied all over the different documents that you could be writing or inspecting, regardless the level of abstraction of the document, regardless the level of the skills of the people in the team. So this is something that we consider like main challenges of this INCOSE guide. So now I start the block speaking about the challenges. I normally like to start speaking about this three-dimensional tailoring space. As I mentioned before, most of the customers that I address, and when I speak about quality rules, then most of them, they say, yes, we do have our own set of rules to be followed. Doesn't matter if it is following the INCOSE guide in any other guide, but most of my customers, they start telling me, yes, we do have our set of rules that we normally check for every single requirements document. But when I ask them to move a little bit around this three-dimensional space, let's say, I ask them, do you normally write requirements at different levels of abstraction? Normally they say yes. And do you normally write requirements of different levels of criticality with different types of requirements in different stages of the life cycle? Of course, you start writing these requirements, but eventually you will end up with the writing. You will get into an informal inspection and then eventually a formal inspection. But when I ask them, okay, so you normally move around this three-dimensional space, they say yes. But when I ask them, okay, and how many sets of rules do you normally apply? One, and only one. It could be INCOSE, it could be any other, but only one. And in our approach, having just one single set of rules is not enough, especially in those cases where, for instance, I can start my career writing requirements for non-critical. I'm a junior guy, let's say, writing requirements for a non-critical component. So it is a low level of abstraction. It is no critical, and I'm still working with in the writing of my requirements. So eventually, after some months or years within my company, I will start doing some formal inspections of the documents written by all of my colleagues. So I am moving, as you can see, in the first dimension of this three-dimensional space. Or eventually, I will end up writing requirements for more critical components. I could be now in the formal inspection of these components, or I could be inspecting high-level requirements documents, right? So at the end of the day, you will find yourself like having the need of writing requirements in different points in this three-dimensional space, and on the contrary, having only one single set of rules to be followed. And this is what we consider as one of the key challenges, not a challenge of the INCOSE guide itself, but a challenge in terms of the way different companies are implementing this guide in daily basis, let's say. So my colleague Elias will provide you with possible solutions for all the different challenges that I'm mentioning here. So first of this dimension, level of abstraction, this is just different examples. So even the INCOSE guide itself in section 1.5 is highlighting that how requirements are expressed differs through these levels of abstraction, and therefore should do the rules for expressing them. So the guide itself is promoting the idea of this evolution or this tailoring of the rules that you apply at different levels of abstraction. But what we find in the common practice in the community of practitioners is that they normally apply one single set of rules, right? So this is just an example of different rules that could be somehow analyzed in different ways when you are at different levels of abstraction. So an example, including now requirements, could be something like this. So something like a revolutionary look and feel, of course, is something. This expression is really ambiguous, but probably at a business level is still okay. While the more you go down to the system or component requirements, of course, the less ambiguous your requirements should be, right? Eventually, at the end, there should be no room for ambiguity in the lowest levels of abstraction of your documents, right? Similarly, we were speaking about different set of quality rules at different stages in the life cycle. Especially this, by the way, this chart or this process is adapted from Carl Wiggers. Of course, when I write my specifications, I should be applying a number of different quality rules, while when I perform the formal inspection of my requirements, the number of quality rules should be different. Following the example before, something like including TBD in a requirement, right in the moment when I am writing down the very first version of my requirement, a TBD, a TBC is welcome. Of course, there is still time to close the gap of provided by this TBD. However, when before baselining, probably a TBD is not welcome at all, right? So this is just to give you the notion of how the rules should be applied differently at different stages in the life cycle, right? Following with this idea of the different phases, I always like to highlight this kind of a chart. I think that you are familiar with this. This is telling us that 70% of the defects that are introduced all along the life cycle are eventually introduced during the requirements phase. Of course, this figure is huge, and this is devastating, especially provided that it is not until testing phase and eventually, in some cases, until operational phase, where we realized of these defects that has been committed during the requirements phase. And of course, the later you fix, the later you detect and fix these defects, the more expensive it will be. So the idea is to help with quality tools and quality rules, to the authors of the requirements, just somehow to reduce this number of 70% as much as we can. But of course, we are all humans. Humans make mistakes, let's say, and probably you will not, or we, in the cases where we apply our methodology, we don't manage to reduce this until zero. This, of course, it's not possible. But at least what we manage to do as well is to increase the number of defects that once are committed by the authors can be detected in early stages of the project, so that if we manage to meet a point in between, then of course the impact in cutting cost, reducing rework, and of course saving time is huge in our projects, right? So the third dimension was considering the level of criticality. Will you be applying the same set of rules to different documents that are addressing different components, regardless the level of criticality of such component? Probably not. Whatever inspection that you do of your documents will take time, will take some very valuable resources. And don't ask me why, but when a project is running cuts and we have to cut here and there and cut corners, most of the times the first activities that are cut are the activities related with quality. So that at the end of the day, we will not find all the time that we would like to find for the activities of checking the quality of our requirements. So the idea is that if we can classify all the different components that are conforming our systems according to the level of criticality within the let's say the product background structure, then we can think of devoting more time to those elements that are more critical and less time to the elements that are less critical. At the end of the day, as I said, everything is a kind of a trade-off between saving time and money and, of course, improving quality. So the more time and money you put for the inspection of your documents, the more quality you will have. But eventually, as I said, probably it is not the same worth to save this time and money in safety critical compared with the non-safety critical components, right? So this is a decision that it is up to you to know to which different documents you want to apply the resources you have for the quality assessment of the requirements, right? Changing gears a little bit now out of this three-dimensional tailoring space, but still within the concept of describing some challenges of the guide. The following challenge is the lack of strictness in the assessment of completeness, let's say. This table here is coming from the INCOSE report, the standards group. I hope you are all familiar with these surveys and these figures that I'm presenting here. If I take all these, this is the success factors according to the INCOSE report. But if now I focus not on the success factors, but on the failure factors, then we can clearly see like the factor which is impacting the most in the quality of our overall project is incomplete requirements. So this should be then, according to this should be the dimension of quality or the characteristic of quality that is more intensively addressed in the INCOSE guide. However, what we find in the guide is not the same. If we look for completeness in the guide, then we can find two characteristics. One, C4, is for the completeness of individual requirements, while C10 is for the completeness of set of requirements. But when we go to the section of the rules and we go to the subsection of completeness, then we only find two quality rules describing completeness, and both of them are not addressing the quality of set of requirements. On the contrary, they are addressing the quality of individual requirements. If we see the overall number of metrics addressing completeness, we find that it is only 3. So 3 is the lowest value for the different characteristics for set of requirements, right? So why is this the case where the standards group is telling us that the completeness should be the most intensive quality characteristic, right, to be addressed? So next challenge is that even if I love the INCOSE guide for data requirements, and I do feel that this is a lovely starting point, as I mentioned, sometimes what I find is that it is tough for unskilled people to start applying these guides. And of course, it is even harder if they decide to follow all the recommendations and all the quality characteristics and quality rules from one day to the other. Probably if I was requesting my customers to follow all these 41 rules, they will kick me away of their offices in the very first minute. So the idea of having just one single step for the implementation of the INCOSE guide is something that normally we have to tailor as well to promote a more gradual implementation of all these quality rules, as my colleague Elias will mention in a minute. Following challenge that we find in the guide is not sufficient support to requirements patterns. Even if there are some quality rules like rule number 1 or rule number 39 that are directly mentioning the idea of requirements patterns or boilerplates, we do think that this is not enough. And by the way, there is no catalog of requirements patterns provided together with the guide, right? So this is something that I hope that eventually soon we could, as a community of practitioners in the requirements working group, provide example of patterns. There are plenty of different examples of patterns, some from Jeremy Dick and this paper with Juan Lawrence. Then in the book Requirements Engineering by Hull, there is another catalog of different requirements patterns, and of course the well-known EARS patterns or the master patterns by Sophist. So these are catalogs of patterns that are available, freely available for all of you if you want to know more about patterns, and hoping that very soon the INCOSE guide or the different documents and guides that are coming now from the requirements working group could cope with this idea of promoting a catalog of different patterns, right? And my final challenge is that it seems, according to the guide, that all the rules are applicable for all the different types of requirements, while normally this is not the case. So a clear example is the rule 16 to avoid negations, avoid not in the requirements. While it is clear that functional requirements should be written in a positive way, most of the times it is not that possible to write safety requirements avoiding the use of not. So the idea is that we like to see all these quality rules like a kind of flexible set of rules, a palette of rules that you can apply for the different types of requirements. But this is not so clear in the guide itself this idea of having the possibility to enable or disable quality rules according to the different types of the requirements, right? So that's all from my side. Now my colleague Ilias will take over and will show you some solutions to these challenges.
Okay, thank you, Jose. So now I will take over the presentation. So now I think you see my screen.
Fine.
So after Jose presented you the reasons why we should consider tailoring of the INCOSE guide for writing requirements and the many challenges that of such an endeavor, let's see some of the aspects of solutions that we can suggest to overcome these many challenges. So to sum it up, first we have to help the requirements authors, not only the quantity analysts, to apply the rules at the earliest stages, as we've seen before. The impact of defining rules at different stages of the life cycle is significant. We also have to address a full concept of rules, relying on an approach based on correctness, of course, but also on consistency and completeness to approach the requirements. We have to follow an incremental methodology to adapt to the context and also to manage the skills and learning of the systems engineers. And all of this cannot happen without an automated support, because obviously this is a time-consuming phase, and we see some of the practical solutions that can help in this endeavor. So, for example, supporting the authoring with patterns, also have different tools to distinguish the authoring and the quality inspection, rely on advanced semantics, and use domain-specific libraries to adapt the rules to the domain of the requirements. As you know, the INCOSE guide for writing requirements sets rules that are not domain-specific, that can be cross-domain. And the idea is to help these rules to adapt in different concepts and different fields. So first, let's introduce you to this well-known systems engineering sandwich theorized by Jeremy Dick. So the idea is that the knowledge is a sequence of requirements and models, and it's important to have the models as an additional reference, an additional source of truth and knowledge. So having said that, models are important to tackle a CCC approach for correctness, consistency, and completeness. As you see, correctness is mainly based on the analysis of individual requirements, whereas consistency and completeness addresses sets of requirements. And as Jose presented you before, we see that completeness of sets of requirements is the characteristics that is tackled by a very few number of rules in the INCOSE guide for writing requirements. So the idea is to tailor this guide using the knowledge in models. And let's take, for example, the example of completeness. So completeness of these requirement specifications. So here you see a product breakdown structure and some transitions that the system here, a computer, have to follow. So for example, we can check the completeness in the PBS. You see that all the elements here are checked with regards to this model, and you see that for the transition Here you see that you can go from normal to low battery, and that each of the states, each of the modes, the normal mode and the low battery mode, are part of this requirement. So they are identified as a part of the model. And then you have the transition between hibernated mode in the hibernated mode, and you have computers and monitors as well. And the last requirement is talking about the weight of the computer. But all the other concepts, system elements, modes, and transitions that are not considered in this specification will give a low quality result if we consider the completeness. So you see that completeness is a very adapted concept. Now, if you consider consistency in the same way, the idea here is to check the relationship between concepts. For example, the computer shall have two monitors. Here we have a direct relationship with these two system and system elements. So we have a check for this one. The second one is not right, because the relationship between computer and engine does not exist in the model. The same thing appears here with relationships. So the transition between two modes, you see that the transition between normal and low battery exists, whereas the transition between hibernated and off mode does not exist. So we have an inconsistency in terms of relationship between the two states, the two modes. And the other consistency that we can check is the consistency against properties in the models. And in this case, you see that the weight of the computer shall be between 1 and 2 kilograms, and we have a weight that is above this range. So it's a bad quality requirement in this case. Then regarding the help of the requirement patterns for authoring, and not only for quality inspections. So here, the help of the quality checking, we can see that, for example, to check the use of the active voice. In this example, we can detect passive voice in any requirement part outside the condition sentence. So here you have two uses of the passive voice, one in the condition and one in the main sentence. And you see that the result shown is only one occurrence of passive voice, which means that we have an understanding that this first part is a condition, and that we sort of want to skip this part of the sentence in the detection of the passive voice. So this is the help, the combined help of patterns and of quality checking during authoring. Then, if we look at the patterns as a help for requirements writing, you see that when you start writing a requirement, if you rely on patterns, you can restrict the possibilities to the slot that is expected in the pattern. So, for example, here we are expecting components, so it will guide the author instead of having any possibility in the knowledge the author is relying on. Here, the choice is to be made between 86 terms considered as components in the knowledge base. So patterns can be a huge help for the requirement authors, and we can rely on several different models and knowledge bases to extract this information. Then another very important aspect of this solution is to have an incremental methodology to tackle the issue of having skilled teams to design these, to implement the rules, and to have this incremental methodology. We suggest to design a roadmap based on the concept of quality belts, like we can see in martial arts, with the idea to gradually increase the complexity of the quality checking and to follow the skills development from the team analyzing the requirements. So you see in this drawing that the more you go up in the complexity and in the belts of karate, the more you see low quality results, which means that the document needs to be improved in terms of quality. So practically speaking, you see that quality belts can be represented as different steps with different notions of the knowledge base. So if you start with a white belt configuration, it means that you only rely on syntax analysis and basically checking if a word is or is not in the knowledge base. So if we take the example of the passive voice, here in this case, it's only detecting the passive voice or not detecting. So the result here would be 2 occurrences of the passive voice in this case. Then if you go up in the complexity, you have so for example, the yellow belt configuration, and here you see that it includes the requirement patterns. So in this case, you can make the difference between a passive voice inside a condition pattern and the passive voice in the main sentence. So in this case, in this particular case, you can consider only one passive voice in the example we've seen before. Then if you move up to the orange belt configuration, for example, this includes also notions of completeness and consistency, which means that, for example, although the pattern featuring the weight of the computer is structurally correct, now with the orange belt configuration, it will be displayed as low quality because of the inconsistency in property. And then you can go up to black belt metric, which doesn't mean that it's the final and final configuration. It can be moved up to a more complex notion. But the idea is that you consider at some point that the quality checking is thorough enough to analyze your document. And another aspect is the use of domain-specific libraries. So as I said before, the INCOSE guide for writing requirements presents rules that can be applied to different sectors of the industry. The idea then is to rely on other libraries, can be dictionaries, glossaries, patterns, and models to create a more adapted context for a specific sector. So we have different libraries here, libraries relying on patterns only, like, for example, requirement patterns from EARS, the Easy Approach to Requirement Syntax, or the master patterns by the Sophist GmbH of Germany. And you also have specific vertical libraries relying on only one sector. For example, the ECSS of the European Space Agency, or the NASA for the space industry, or the ISO 26262 for the automotive industry. You can see more content on these libraries following our webinar section on the link on the bottom left of this slide. Then to sum up, to embrace all these different solutions and to rely on an automated environment, one solution is the Systems Engineering Suite. As you see, there are different tools that tackle different aspects of requirements quality assessment and requirements authoring. So you see that there's a tool specific to the quality of the requirement specification, one tool focusing on the authoring and the help of requirements writers at the early stages of the requirements phase. Then you have a knowledge manager. So as the name suggests, it helps managing the knowledge and the connection to other model-based system engineering environments. And you have a traceability studio, which allows to follow traces between different types of artifacts. So these environments have the interest of connecting with different repositories. For example, the quality analysis can connect to different requirements management tools, and the authoring tool can be used as a plugin into several of the requirements management tools. So then you can also think about combining the system engineering suite with artificial intelligence. So you see that, as I've told you, manual definition of the rules and manual verification is a time-consuming process and would require an intensive help from the experts of the field. So you see that, especially for the ontology building, it takes a lot of time, whereas using a combination of the artificial intelligence and the natural language processing of the system engineering suite, you get reduction of time and less help from the experts of the field. So now I hand over to you again, Jose, so that you can show us the quiz.
Yep.
So
yes, thank you, Elias. Now this is just my final word. I have prepared a small quiz. If you can follow this link, it is going to take us just a minute. I think you can click on the chat box if you have one additional minute before we wrap up, just to follow a quiz. So please enter or click on this link if you want to participate, and you will face a web page, and you will be asked first for a PIN. The PIN that you will have to provide us to participate in this quiz is this one. So I'm pasting this PIN number. Wow, I see some people joining. So I give you some few seconds for you to join. You can use your own your real name, or you can use a different name if you wish. So please don't be shy. Your experiences will leverage the way we all do systems engineering. So please keep joining. I have 7 people joined so far. 8, good. There's no need to provide your own initials or your real name. You can just, as many people are doing, just say A, B, C, or whatever. Okay, I think we can start now. Final 5 seconds if anyone else wants to join. Perfect. 3, 2, 1. Okay, I start. So now you will find 6 questions, and you have 30 seconds to answer each of them. So the first one is, I use the following set of rules for the inspection of my requirements. You will see in front of you just the 4 buttons, red if you use the INCOSE guide, blue if you use the rules from other standards or handbooks, yellow if you use your own custom set of rules, and green if you are not using any single set of rules. Good. So it seems that 3 of you are following the INCOSE guide, 3 are following your own custom set of rules, and 2 of you are using rules from other standards, and 2 are not using any set of specific rules. Good. Second question. This question is multi-choice, let's say. So I normally use a standard set of rules, but the rules are tailored according to the level of abstraction, according to the life cycle. So red for life cycle, blue for level of abstraction, yellow for to the level of criticality, and green is if you always follow the same set of rules regardless any of these dimensions. Good. So nice answer. Getting to the third question. My quality rules are mostly focused in only correctness, that is the quality of individual requirements, correctness and consistency among requirements, or consistency between requirements and models, correctness and also a little bit of completeness, or the full CCC approach, correctness for individual requirements, but also consistency and completeness for requirements and models. Wow, I love this answer. Great. Concerning the use of patterns or boilerplates, red, I prefer free typing. Blue, I use some patterns, but just as a reference. Yellow, I use some patterns and encourage to follow the patterns. Or green, I have never heard of this concept of patterns or boilerplates. Okay, we have all of our answers. So it seems that most of you use patterns and encourage the use of patterns. Lovely answer as well. Fifth question, this is multi-choice again. I know and apply the following catalog of boilerplates or patterns. Red for the EAS patterns, easy approach for requirement syntax. Blue for master patterns from Sophist. Yellow, the patterns provided by or encouraged by Boeing company. And green, other catalog of patterns. Good. So I would love to receive answers like what other catalogs are you using? If you can just drop me an email and keep me informed of these options as well. By the way, I will send you through Tammy. I will send you all the conclusions or all the answers to all these different questions. And then the final question is, just one final question is, I use tools to enhance the requirements assessment process. Red is yes, we develop our own set of tools. Blue, yes, we purchased a tool. Yellow, no, but I would like to give it a try. Or green, no, and I don't plan to do it. Good. So now we have all the questions. Okay. So if you want to give it a try, don't hesitate to contact us. And then just thank you for the answers. My very final slide is, as I mentioned, we have just released our book, a tailoring guide for real-time quality assessment of the INCOSE guide for writing requirements. If you want to request your own copy, just take this link. I will copy the link and paste the link in the chat box if you want to have it in the chatting box.
I was going to ask you to put it there. And we were going to put it on the requirement working group Connect site as well, along with the slides for today's meeting.
Perfect. So that's all from our side. Thank you very much for your attention. I don't know if there is room for questions, Tammy, or...
We do have time for questions. We've got about 5 minutes until this time is over. So if anybody has any questions, it's an excellent time to go ahead.
This is Lou. I want to point out that your conclusions about correctness or completeness, are extremely valid. The problem we have with the guide to writing requirements, the focus is writing textual statements and the wording of those textual statements. The problem with completeness of the set is it's beyond the text statements themselves. And so in the products that we're working on, I've been working on the needs and requirements lifecycle manual. I'm spending a lot of time talking about completeness of the set, and a lot of times with the completeness is about it's more process than it is just the wording of a requirement statement. And so there is a lot of capability we have now because we're developing different documents to include more guidance to achieve completeness. Maybe not specific rules, but there's a lot of guidance to ensure that you have a complete set of requirements.
Thank you, Lou, for your question or your comment. Yes, in our experience, completeness is the most challenging of these 3 dimensions: correctness, completeness, and consistency. We know that there are some companies applying a kind of a checklist to tackle completeness. So not to forget any single stakeholder, or not only to consider the inner system, but also the, as some people know, the onion chart, or to think of requirements at different stages, not only thinking of requirements for the operational phase, but also for maintenance or even disposal. So I know that there are some sort of checklists on this topic. By the way, if you are interested on completeness, I was presenting a webinar on this topic some time ago, so you can go to our website and click on resources and webinars and browse to completeness. But in our approach, and this is why Elias was presenting this idea of the sandwich model. The idea is when we have the possibility to have and develop at the same time requirements and models in this layered approach, then we have the possibility to use the models as a kind of source of truth, so that we can compare the information we have in the requirements with the information we have in models. This is our approach that, of course, can combine together with the approach that you mentioned to tackle the challenging dimension of completeness. Yeah,
and that's exactly,
I do believe that the common approach is the best solution. Yeah,
and that's exactly the same approach that's being reflected in the manual.
Yeah.
Yeah, and for those of you who aren't aware, Requirement Working Group is working on 3 new products. Lou mentioned the Needs and Requirements Lifecycle Manual. That's the one he's helping oversee. We also have the Requirement Management Guide and the Guide to Verification and Validation. So we're pretty excited about the work going on this year with all of this material. Any more questions for Jose or Elias?
Hi, I have a question. Jose, have you used or had experience in using this approach within a product line engineering kind of environment where you not only have your typical requirements, but they're instantiated across multiple levels with, say, like each model as well? How does that differ at all, or do the same principles apply, or can you comment on that?
Well, I think we do need a full 1-hour webinar to address this question. Yes, we have participated in a very interesting 3-year project, research project funded by the European Commission, especially on this topic. So I can share in a minute. I cannot share any conclusions with you, but yes, we have applied this approach. Of course, the more you move into requirements reuse, the most important is the concept of quality. If reuse is a kind of G.I. Joe system, garbage in, garbage out. So if you put low quality assets let's say to be reused as a product in a product line approach, of course, what is reused will be garbage as well. So the idea is first start with high quality assets in this approach, but we have applied these or approaches to automatically generate common requirements, defining commonalities and variability just by analyzing a set of different requirement specifications. We have also applied the possibility to automatically write textual specifications just based on patterns and based on the idea of having the actual values for one particular member of the product line, one particular instance of this product line, just by filling out a table with the different properties or values, so that this table automatically, based on patterns, will populate or instantiate textual requirements. So all this approach has been followed in this project and has been implemented so far today in a small number of customers. But if you want to learn more, just drop me an email and we can discuss a long time on this topic.
Requirement reuse is a great topic, Jose, I think on its own for a working group session.
Yeah,
yep.
Definitely.
Thank you.
Thank you.
All right, I think that does draw us to conclusion. We are not going to have a requirement working group meeting in July because we do have the IS 2020, and I hope that many of you are able to participate in that virtual event this year. And then we'll go ahead and meet again near the end of August, and I'll put out an announcement. Bill Bearden is going to talk about the IEEE standard for the requirements 15-88. So he's on the committee working that. So that'll be our next meeting in August. And until then, I'm going to go ahead and stop the recording, and we will be putting this information on our requirement working group SharePoint site. Thank you all very much, and thank you to the speakers. I really appreciate you guys giving us your time today.
Thank you very much.